Okay, figure P-31 is used, we can do it as a revolve, and the tendency is to put the circles into this section, but it does not follow around. All right, so this is going to be a cut. I cannot drill in 270 degrees. But I can drill and tap, do whatever we need to do, and based on the isometric, there'll be a little fingernail and a little fingernail at each of those corners. So when we do a revolve, we cut the part in half, and then we cut it in half again. So really what we're interested in is this profile shape and the center line to act as an axis of revolution. So when we draw this, if we go right to the center line, then there won't be any type of hole through. If we want to create the geometry with the hole, then we're just going to offset that line, the distance, either radial or diametral distance from the center line. All right, so revolves are really handy. If we went to do this as an extrude, we might draw this geometry, extrude it up some distance, draw another partial and extrude it up, and then we would have a stack of 3 or 4 features. We're still going to end up with a couple of features, but a lot of times with the revolve, we can get quite a bit of geometry, usable geometry in one shape. The other thing is that since the majority of this would be made on a lathe, um, cylindrical parts are just handy that way. We would go ahead and work with that geometry as a revolve. So horizontal infinite length, if it is revolve or symmetric, I'm going to do that infinite length center line. In this case, setting it up to look like the figure. Then we place it on the origin, escape out of it. I can go L on the keyboard, and we'll draw that quarter cut shape, and then we're ready to add dimensions. All right, so our overall was 60, the step is 20. We're going to go into the diameters. So when I pick the center line, if I stay between the object and the center line, I'm getting a radial distance. If I go to opposite the center line, then I'm going to get that diametral distance. So that becomes 16. The outside is 22. The little d is telling me with the cursor that I'm going to stay in diametral until I escape or in the dimension command. And so I can just keep clicking on those until I have applied my dimensions. So everything looks good. I'm still not fully defined. So I'm just going to hit escape, and I'm still in dimension, and escape one more time puts me back to select. So when I grab this, it's able to move left or right. I want to relate this to the origin. So picking the line and the origin would be coincident. The other option would be a point and the origin, so 2 points, and make that vertical. Those are pretty much the two choices here, so let's stay with that, and I'll just make it coincident. Then we go in and do a revolved boss base. It's going to be 360 degrees, and the line doesn't necessarily have to revolve. The rule is that it cannot self-intersect, so that's a valid solution. That's a valid solution. That is not a valid solution. And that one, a valid solution. All right, so center line is going to generate the most of the geometry that we want and be able to complete. Opening up a sketch on the in face. Let's go ahead with, we need 2 pieces of geometry, so let's go with the X, and I'll just bring the circle in with a convert. And they're kind of hard to tell sometimes, a little darker. So let's go ahead, and we're going to go into the extruded cut. My from will be a surface. So I want to cut, um, actually, I do want to cut through pretty much all of that. So let's go and just, we'll stay in the sketch plane on this one. And I will cut, we need this quadrant on the upper and this quadrant on the lower. Okay, so had to make sure I knew what I was looking at there. So if I pick that one, well, it picked the region and found the edge. I don't think I converted anything there, but if it wants to include that, is that going to hurt anything? Probably not. Yeah, it would pretty much pick that geometry. I just want to do a reality check before I commit to it. And this is going to go to 20 off of the end. So playing with the end conditions to kind of figure out what I want to tell it to do. I'm going to go this way, 20 millimeters, and that looks like on the preview I'm getting what I want in the cut. All right, going back in, I'm going to expand out the little arrow, pick sketch 2 again. We're going to go with the extrude cut. This time I'm going to pick that lower quadrant. Now I need the from surface, and we'll go from that face, and it can just go through all at that point. It will terminate at the end of the geometry. We go ahead and make the cut. All right. So let's go ahead and introduce or revisit the hole wizard. So I want to pick a face, and we'll go with the hole wizard. Again, the hole wizard advantage here. We'll go Control 8, Normal 2, and pre-selecting. I'm going to be on that face already, but the advantage here is if I decide to go from a standard through hole to a tapped hole to something else, that geometry becomes a little more accessible. All right, so drill sizes, apparently the last hole wizard I did was this one. If we don't, we're going to set to metric. Pick the drill sizes. A dowel hole isn't going to help or hurt. It does change the symbol in the drawing. And then once we have the 5 millimeter, we're going to tell it to go through all and set our position. So we'll have 10 millimeters from the face and 5 millimeters, 6 millimeters. Okay, and then we can complete it. And I'm going to want to tie these together. So if I show my sketch, I'm going to be able to see that point. And this one, I'm going to go into the hole wizard. Well, I got ahead of myself there. I'm going to go into the hole wizard without pre-selecting. And all of our settings should stay the same from one selection to the next. All right, so we're just going to check metric drill sizes 5 millimeters. If you see the 3D sketch, go into the work area and pick the plane that you want. 3D sketch is more fun than we want to play with right now. So our 6 millimeters off of the face is fine, and I want to tie these two sketches together. And again, because of the projection, because I can take this point and project it into my sketch plane, I can make those vertical. And then now if I need to change the distance this way, both of those will change together. And then if I go isometric, just start to see the little fingernail, just start to see the little fingernail of the ellipse. And we do a quick check and we have our geometry. So we'll go ahead and save this one. And call it good.